In this video, we're going to look at one more question to find out the inverse of a matrix using elementary row transformation. So my question says find A inverse using elementary row transformations, and this is the matrix A. And we know the method. To start with, we write the relation, basic relation, A is equal to I into A. Any matrix A can be written as I times A. And remember, we keep I first when it is row transformation, and we'll write A into I. That's just the format to remember, A into I if it is column transformation. Anyway, we are not going to look at column transformation. This is row transformation. So A is equal to I into A. On the left side, A will be replaced by its corresponding matrix. On the right side, I, since A is a 3 by 3 matrix, my I will be a 3 by 3 identity matrix. 1 0 0 0 1 0 0 0 1 into the other A will be left as A itself. Now looking at the steps, we want the left hand side to become an identity matrix, which means A11 should be 1, make A11 as 1. So I want this element to be 1, and once I make that 1, I'll make the remaining elements into 0. Then A22 as 1, then up and down 0, then A33 as 1, remaining elements there in the third column will be zeros. So this is what we do. So to start with, I want A11 to be 1. To make 2 into 1 using 5, difficult. What I can do is R1 changes to R1 divided by 2. As I told you before, you could do that if you are comfortable with fractions. You can reduce the number of steps then. But if you don't like to do fractions from the very beginning, avoid that division at that stage, and you could say interchange between R1 and R2. Now let's see how it helps. R1 and R2 is being interchanged. That's my operation. So if I'm changing R1 and R2, I know R3 is remaining the same. So whichever row remains the same, which is not under change, copy that. So 0 1 3 0 0 1. The third row I copy throughout. Not just the left side. Whatever I do on the left side, I do it on the right side as well. So I copied my R3 throughout. Now I'm going to interchange between R2 and R3. I'll pick up my R2 from here and place it in the first row's position. So my R2 is 5 1 0 0 1 0, which I wrote in R1's place. Now I'll take my R1 from there and put it into the second row's position. So R1 from there is going to the second row. So that's interchanging R1 and R2. Still again, what we are looking for is A11 to become 1. In place of 5, I need 1. And what I have below that is 2. So how can I make use of this 2 to make 5 into 1? 5 minus 4. 5 minus 2 times 2. But I can't do just with one element. So I will be saying, instead of 5, I will say R1. So R1 changes to, from R1, subtract double of R2. So R1 changes to R1 minus double of R2. What was the logic? I want 1 there. So 1 will be like 5 minus 4. 5 minus 2 times 2. So 5 minus double of 2. So but I can't say 5 and 2. Instead I say R1 changes to R1 minus double of R2. R1 changes to R1 minus twice of R2. So let's do that operation. So R2 and R3 will remain the same. So after I will be copying R2 and R3 as it is, because only R1 is under change. Let me copy R2, let me copy R3. Now I'm going to go for this operation R1 minus twice of R2. 5 minus twice 2. 5 minus double of 2. 5 minus 4 is 1. 1 minus 2 into 0 is 1. Then 0 minus twice of minus 1. 0 minus minus 2. 0 minus minus 2 is 2. On the right side, 0 minus twice of 1. 0 minus 2 is minus 2. 1 minus 0 is 1. And 0 minus 0 is 0. So that's what I have there now. So I did that operation. R1 changes to R1 minus twice of R2. You should slowly stop the video and do it yourself and see. And now, once I make A11 into 0, all the remaining elements in that column should become 0. So I'm just copying what I had in the earlier slide. I'm just copying that one more time. This is where we reach. Now since my A11 is 1, all the remaining elements in that column should be 0, which means now this 2 should become 0. Now for 2 to become 0, from 2 I should subtract a 2. And where can I get a 2 from? Double of 1. But I'm not operating between 2 and 1. I am operating between the second row and the first row. So I'm saying the operation is R2 changes to R2 minus double of R1. What we are looking for is 0 in this position. For 2 to become 0, I should do 2 minus double of 1. So I will say second row changes to second row minus twice of first row. R2 changes to R2 minus double of R1. R2 changes to R2 minus twice of R1. So let's do that operation. If we are doing that, only R2 is changing, which means I should be copying R1 and R3 as it is. So I copy my R1, 1, 1, 2, minus 2, 1, 0 as it is, and my R3, 0, 1, 3, 0, 0, 1 as it is. So I copied my R1 and R3 exactly the same. Now R2 minus twice of R1, 2 minus twice of 1, 2 minus 2 is 0, 0 minus twice of 1, 0 minus 2 is minus 2, and minus 1 minus twice of 2, minus 1 minus 4, minus 1 minus 4 is minus 5. 1 minus twice of minus 2, 1 minus minus 4 is going to be 5 there. 0 minus twice of 2, 0 minus 2 is minus 2, and 0 minus twice of 0, 0 minus 0 is 0. So we did that operation. So what we did here until now is we made A11 as 1, got the remaining elements zeros. What do we need next? A22 should become 1. And you should never involve R1 for that, because then R1 if I use for anything, I will lose this existing 0. So it's anything I do should be between R2 and R3. So I need 1 here. Oh, there are 2 ways of doing it. One is take 3 times R3 and add it there. 3 times R3. Why 3 times R3? 1 into 3 is 3, and 3 when I add to minus 2, it will become 1 there. That's one operation. So one possibility is R2 changes to R2 plus 3 times R3. Another possibility is simply interchange between R2 and R3. I prefer that. I'm going to say R2 interchange with R3, which means my R1 remains the same. So I'll copy 1, 1, 2, minus 2, 1, 0. The first row the same, and you are interchanging between R2 and R3. You take the second row and put it in the third row's position. Third row 0, 1, 3, 0, 0, 1. 0, 1, 3, 0, 0, 1 goes to the second row, and the second row will go to the third row's position. Now that I have A221, I want the element above that and below that to be 0. Let me copy that step one more time here. So I have the same step copied here for my convenience. And I know A22 is 1. I want the element above that and the element below that to be 0. So how would I get the element above that 0? R1 minus R2. 1 minus 1 is 0. How would I get this element 0? Minus 2 as 0. Minus 2 plus 2. Minus 2 plus 2 means what? Minus 2 plus 2 times 1. So minus 2 stands for R3. And 2 times 1 means 2 times R2. So I think I figured out both the operations. If I want 0 there, I will say R1 minus R2. R1 minus R2. 1 minus 1 will give me 0 there. And how will I get 0 in this position? R3. It's on R3. R3 changes to R3 plus twice of R2. R3 changes to R3 plus twice of R2. To minus 2, I add double of 1. So minus 2 plus 2 will make it 0. So R3 changes to R3 plus twice of R2. R3 plus twice of R2. So these are the operations. So let's do that operation. So your R1, R2 alone remains the same, because R1 you are changing, R3 you are changing. So let's copy R2 the same. 0, 1, 3, 0, 0, 1. I copy the same. Let's work on R1. R1 minus R2. 1 minus 0 is 1. 1 minus 1 is 0. 2 minus 3 is minus 1. On the right side, minus 2 minus 0 will be minus 2 here, then 1 minus 0 will be 1 there, and 0 minus 1 will be minus 1. And with R3, we say R3 plus twice of R2. To the third row, you add double of R2. 0 plus twice of 0 will be 0. Minus 2 plus 2 times 1. Minus 2 plus 2 is 0. Minus 5 plus 2 times 3 is 6. Minus 5 plus 6 is 1 there. 5 plus 2 times 0 is 5. Minus 2 plus 2 times 0 is minus 2. 0 plus 2 times 1 is 2. The next element what I am looking for is A3, 3 should be 1, but luckily for us it's already 1. Now if that is already 1, in the previous question when we did it was not 1, it was, I think it was 5 there. So what we did is we said divide R3 throughout by 5. So whatever number comes here, divide throughout by that number. That's a fixed step. But luckily for us in this, A33 is already 1. So just make the previous elements into zeros. So I want 0 here. Minus 1, how would I make it 0? Plus 1. So isn't it going to be R1 plus R3? And how will I make 3 into 0? 3 minus 3. How would I do that? 3 minus 3 times 1. So can I say that is same as R2 changes to R2 minus 3 times R3. So I have the two operations. One is R1 plus R3 because minus 1 plus 1 will make it 0. And the next is R2 changes to R2 minus 3 times R3. If I want 0 here, R2 changes to R2 minus 3 times R3. Because 3 minus 3 only will get me 0 there. So 3 minus, where do I get 3 from? 3 minus 3 times 1. But 3 stands for R2. So R2 changes to R2 minus 3 times 1. 3 times R3. So R2 changes to R2 minus 3 times R2. So you are going to change R1. You are going to also change R2. What is staying the same is only the third row. So let's copy the third row the same. 0, 0, 1, 5 minus 2, 2. I copy the same. My R1 is changing as R1 plus R3. So let's do that. R1 plus R3. To the first row, you add the third row. 0 plus 1 is 1. 0 plus 0 is 0. 1 plus minus 1 is 0. Also on the right side, 5 plus minus 2 is 3. Minus 2 plus 1 is minus 1. And 2 plus minus 1 is 1. And with R2, we say R2 minus thrice of R3. From the second row, subtract 3 times the third row. 0 minus 0 is 0. 1 minus 0 is 1. And 3 minus 3 is 0. On the right side, 0 minus 3 times 5. 0 minus 15 is minus 15. 0 minus 3 times minus 2. 0 minus minus 6, which is 6. 1 minus 3 times 2. 1 minus 6 is minus 5. I got I on the left side. So I is equal to B into A. So this is my I is equal to some. So what I have got now is this is I on the left side. I is equal to some B into A. I is equal to B into A. If I is equal to B into A, then B has to be the inverse of A. That's why the answer is I. So I will say B is A inverse. So here I have I is equal to some B into A. So this B has to be the inverse of A. So I say therefore A inverse is equal to this matrix. So you should pause the video here, copy the question and do it yourself. Copy it, first copy it down from what I have done, but then redo it yourself and see whether the answer matches. You could deviate from the steps, you could use your own operations, but make sure that your answer comes correct. Only after practicing that question or previous 2 questions from the previous video as well, you should try to do these 2 questions for homework. And once you get the answer, how would you verify? Whatever answer you get for A inverse, you multiply with your original question. So that's my A, and the answer which you get is your A inverse, and you multiply them and see if the answer is I. If the answer is I, what you have done is correct. Your A inverse is correct. We're going to look at another question. This is a 2 by 2 matrix. That's the only change. And the question still is the same. Find the inverse of B using elementary row transformations. So this is named as B. So I'll write B is equal to I into B. And I will replace the B on the left side by its corresponding matrix. But the right side B I'll be leaving as it is. But I. In the earlier questions, we had 3 by 3 matrices, but here I have a 2 by 2 matrix, so my I has to be 2 by 2 as well. 1, 0, 0, 1. Into this B is left as it is. What's our aim? We want to convert this into an identity matrix. For it to be an identity matrix, it should look like 1, 0, 0, 1, 1, 0, 0, 1. So if I need to have 1, 0, 0, 1 here, I already have 1 luckily here. My A11 is already 1. So the element below that should be 0. So I want 0 in this place. In the place of 2, it should become 0. How does 2 become 0? 2 minus 2. 2 minus 1 into 2. But 2 stands for second row here. So second row changes to R2 changes to R2 minus twice of R1. That's how I would get 2 minus 2 as 0. So R2 changes to twice of R1. I will copy my R1 as it is because it is not under change. 1, 2, 1, 0 I copied. And R2 minus twice of R1. 2 minus 2, 0. Minus 1 minus 4 twice of R1. Minus 1 minus 4 minus 5. 0 minus 2 minus 2. 1 minus 0 is 1. So this is what I have here now. And now, once I have A11 as 1, the remaining element should be 0, which is done. The next step is A22 should be 1 and the remaining element should become 0. So I need A22 to be 1, which is minus 5 at the moment, but that has to become 1. And that's a fixed step. For the very last element, we just divide throughout by that number. So I'll say R2 changes to R2 divided by negative 5. And if I do that, what do I get? First row remains the same because it is not under change. 1, 2, 1, 0 remains the same. Second row is divided by negative 5. 0 by negative 5 is 0. Negative 5 by negative 5 is 1. Negative 2 by negative 5 is 2 by 5. 1 by negative 5 is negative 1 by 5. So I have my A22 as 1. So the element above that has to be 0 now. This 2 should become 0. How does 2 become 0? 2 minus 2. Isn't it R1 then minus twice of R2? So my operation I figured out. If I want 0 there, it should be 2 minus 2 times 1. So R1 changes to R1 minus twice of R2. So this time my R2 remains the same. So I'll copy my R2 the same. 0, 1, 2 by 5 minus 1 by 5. But I am now supposed to do first row minus twice of R2. 1 minus twice of 0 is 1. 2 minus twice of 1. 2 minus 2 is 0. On the right side, 1 minus double of 2 by 5. I did that calculation here. I don't want to do it in my head and get it wrong. So 1, R1 minus twice of R2. 1 minus twice of 2 by 5 is 4 by 5. 1 minus 4 by 5. Take LCM. 5 minus 4 is 1 by 5. And then 0 minus 2 by 5 twice. 0 minus 2 by 5. 0 minus twice of this element. 0 minus 2 by 5. So that would be plus 2 by 5. I think I copied it wrong here. This element is now supposed to be 0 minus 2 by 5 is actually 2 by 5. So this element should have been plus 2 by 5. So this is, I think I got that wrong again. So that was actually correct. Yeah, so 2 by 5, that's right. So that's some matrix into B. So where did I reach here? So I have this matrix into B, and so if I is equal to a matrix B, a matrix C into B, then C has to be the inverse of B. So this is the inverse of B. So B inverse is equal to that. I just slightly messed up there saying, so you should redo it yourself and see. We're going to look at one more last question here, 55, with a special case. B is equal to this one. You will realize it towards the end. I want to find out the inverse of my B. So we say B is equal to I into B. I copy my B on the left side as it is. The right hand side identity matrix has to be a 2 by 2 because B is 2 by 2. My I has to be 2 by 2 as well. So 1, 0, 0, 1 into B. If this is the given matrix given to me, what I have to finally get is identity matrix on the left side. Identity matrix on the left side means A11 has to be 1. I need to get 1 in this place. And using 10 and -5, I don't know how to get 1 there. So it looks like a little difficult for me to get 1 here in place of 10 using -5. So I don't mind dividing by 10 then. So I'll say R1 changes to R1 divided by 10. Because it's only 2 by 2, I don't mind having fractions, just 2 steps of calculation. So dividing the first row throughout by 10, 10 by 10 is 1, minus 2 by 10 is minus 1 by 5 is equal to 1 by 10 and 0 by 10 is 0. So that's your first row divided by 10. Second row, we did not do anything, so I'm just copying minus 5, 1, 0, 1 into B. Now once you get A11 as 1, we want all the remaining elements in that column, the element below that, to be 0. How do I get minus 5 as 0? Add a 5. Minus 5 plus 5, which means what? Minus 5 plus 5 times 1. So the operation would be R2 changes to R2 plus 5 times R1. To -5, I should add 5 times 1 to make it 0. So we are going to copy the first row the same. I copied the first row the same. Now 5 times the first row should be added. R2 plus 5 times R1. -5 plus 5 is 0. 1 plus 5 times -1 by 5. What is 5 times -1 by 5? -1. 5 times -1 by 5 is -1. -1 when I add here, that's going to be 0 there. And you multiply this by 5. 5 times 1 by 10 is 1 by 2. Add it here. So 1 by 2. 5 times 0 is 0. Add it here. 0 plus 1 is 1. What I have to do next is A22 should be 1. And this 0, you cannot make it as 1 in any way. Whatever you try to do here using the previous row, you will lose this 0. So since this element turned out to be 0, I can't make this into 1 anymore. And if I can't make this into 1, I don't get I on the left side. So you are stuck. So how would you realize it so quickly now? Anytime when you do elementary row transformations, on the left side, if one row completely becomes 0, like now this case, one row fully became 0, all the elements of the second row became 0. And then we say this cannot be any further made into identity. So that means I can't find the inverse. So A inverse or B inverse in this case does not exist. And this is how you would conclude. Since all the elements of R2 became 0, B inverse does not exist. But what's the logic behind that? You need to understand. Once this element is become 0, I cannot change that into 1. So that means I can't get identity matrix on the left side. So if you get all the elements of a row as 0, then we say the inverse does not exist. So you have got 2 questions for homework there. Those 2 should spend time doing them. And also you can verify your answer if you wish. Please practice these questions over and over.